This is the final project presentation of Group 6, the step counter, and sometimes known as the pedometer. The group members are listed as follows. Here to mention the work division. All of us participate in coding. Most of the academic research and raw data came from Tuyuexin, and I do the data analysis plus the editing for this video. As for Huang Jianzhou, he designed the app to visualize real-time data plus filming our experiment process. Using MATLAB Mobile allows us to acquire data from the built-in sensor in our device and send this data to a MATLAB session running on the computer for further analysis and visualization. But for this project, we will only use the acceleration sensor, and the magnitude can be easily calculated. Thus, most of our data analysis are doing in one-dimensional space, which is fast to analysis, also great for fast Fourier transform. With the idea of Gaussian naive Bayes classifier, we assume the continuous value associated with each steps are distributed according to Gaussian distribution. To avoid the recount of data point, we only count the peak, which have to be twice the standard deviation larger than mean as well. Here is a basic demonstration of the step counter app. At the left-hand side, you can see our app recording the data from sensor, and the right-hand side is the test subject walking. After capturing the data we need, the program will give us the total steps and the FFT after a short period. The following is the in-depth analysis of the app demonstrated by Huang Jianzhou.
In this part, I will talk about how our code works. First, we talk about the basic concept of our project's code. We enable the transmission between mobile phone and computer here, setting the sample rate to 100 here, and set mlogin to be 1 in order to record data here. And the while loop, first, in this code, we transmit mobile data into A and T matrix. A is the value of 3-dimension accelerator and T is the time of point. We transmit the data every 1 second. And here's the first figure. The first figure plots the value of 3-dimension accelerator. And here's the second figure. As you can see, the second figure plots the value of net worth, which is the square root of the sum of the square of each data. And here's the third figure. The third figure plots the net worth with no offset, which is the net worth minus the mean of the net worth. Then at last we count the steps. Our method to count the steps is to pick up the value which is beyond 2 standard deviations. The last figure here plots the FFT of the whole value. Now I am going to describe how we make the UI of our project. First of all, we can easily design our UI style by using the function of App Designer in MATLAB. For layer 4 objects to show in our step counter project, here's our design. As you can see, layer 4 UI exists to show our plot, 2 buttons to start and or end, and area for counting steps. And I will start describing our code in UI. First, in the function, creating component, App Designer automatically creates the functions which generate things like UI axis or buttons. So we just need to modify the parameter in this part to make it become much prettier. Second, we have to edit our code in combinational logic instead of in sequential logic in order to make it available in our application. Consequently, first, we need to create timer. And here's our timer. Timer plays the same role with clock in Verilog. With the help with timer, we can make our app update with a constant rate. In every clock, we conduct an update function, which I have already described in a previous part. And here's how we use our timer to use the update function. And next, we define how our buttons work. When we push start button here, start button push, our app will be connected to our smartphone. Start recording the acceleration data and plotting the wave output on the UI axis. When we push the end button, we will end recording the data, plot the FFT result, and clear the data we have recorded. And here's our end button. FFT end button function is written here. Here's our function. And this is the end of UI design and our basic concept of coding.
The following are 4 different types of situation using step counter, which are walking, running, going upstairs, and downstairs. Let's start with the simplest case, slow walking. Now you can see at the right side is the acceleration magnitude of walking during 10 seconds. But there exists some peak which should be counted as a step didn't get detected. The easiest ways to improve this is to lower the threshold. Let's try lower the minimum to 1 time of this standard deviation. The steps increase as wanted, but this only works when the test user is walking. Let's take a look at another case, running. Compared with slow walking, the diagram of running is easily to identify the existence of a periodic signal. If we take a closer look at the signal, we will find every big peak is followed by a smaller peak. It is because the phone is put in the pocket during the run. Most of the time the phone is weightless, depending on which side user places the phone. One footstep will abruptly increase the magnitude, but the other side won't, and make the little peak right after the large one. This kind of step did not get detected even with lower threshold. To get more precise result, we apply the sliding window FFT as Professor suggests during the midterm presentation, and calculate the mean of all frequency domain diagram as our final result. In this project, we normally use window size of 300 sample points, which should be 3 seconds period in time domain. After the FFT, we can use the frequency of running to decide the minimum period between 2 steps, noting it is a period of 2 steps, so we need to divide it by 2. Now, let's try about walking upstairs. As you can see, after every large peak, there will be another smaller signal following, which is nearly flat, so it is hard to detect a peak. Now, if we apply FFT and get a frequency, the advantage of FFT is that we can lower the threshold even more, so finding a peak can be much easier and the result is very accurate. It is interesting that walking downstairs is quite similar with upstairs. The same characteristic of signal appears, and we apply FFT to get a significant frequency. Without a doubt, now we don't suffer from miscount or double count a step. The final results are just like we desired. That's all for our final project presentation. My name is Chen Hanqun, and thanks for your watching.